Hey everyone, I'm here with Dr. Tracy Fanara, environmental engineer and hydrologist, and today we're going to be talking about nutrient pollution. I first wanted to broadly define, what even is nutrient pollution in the first place. I feel like it's a pretty big buzzword right now. We see nutrient pollution issues all the time, but I think we can start by clearly stating what it is and the different types of nutrient pollution, and if this problem is getting worse.
People talk about nutrient pollution. I would never say nutrients are pollution, but they can be seriously problematic in high quantities. Nutrients feed life, and they feed us. But too much of a good thing is never a good thing. Like too much chocolate cake, you got some problems after a while. Trust me, I know firsthand. So nutrient pollution, in that sense, has been problematic throughout the entire country. Throughout the entire world, we have problems, especially with cyanobacteria and harmful species of cyanobacteria like microcystis causing water problems worldwide. So it's not just here, and there's not just one place. The Mississippi River, for example, 40% of the United States flows into the Mississippi River, Mississippi Atchafalaya watershed. Like, isn't that crazy? Like, to think about how much area we have literally manipulated to drain into one space. And then I don't know why it's news that we have the second biggest hypoxic zone in the world at the mouth, the mouth of the Mississippi. But we have nutrient pollution coming in from wastewater treatment plants, from agriculture, from urbanization, fertilizer, from all these places, industry coming down and going out to the northern Gulf of Mexico. All of that nutrients is causing algae blooms that are growing like crazy, blocking out sunlight, causing hypoxia right there. But also, when these blooms start to die and decompose, that process uptakes oxygen further, and we have the second biggest dead zone in the world. Over here in Florida, we have Florida Bay that's suffering from salinity changes. We have the Caloosahatchee River that suffers from discharges from Lake Okeechobee. We have Tampa Bay that suffers from not only the wastewater spills that you've heard in the news, but also from urbanization and changing landscapes in that way. We have over on the St. Johns River, we have saltwater encroachment. We have the Indian River Lagoon, which you've heard at over 10 years has caused such a regime shift that the benthic organisms and seagrass can't grow back, which have resulted in a mass manatee mortality event. We have so many issues going on in the state of Florida, but the one thing that we can save right now are the Everglades. And the way we do that is treating the water, removing nutrients from Lake Okeechobee, and replenishing the thirsty Everglades with that water down south.
So when we talk about nutrients and nutrient loads, what are some of the different types of nutrients that exist, and are all of them problematic or just some of them, or how does that all work?
That's a really good question, because there are so many different chemical compounds and elements that consist of nutrients. For example, iron is a micronutrient. But normally when we're talking about nutrient pollution with water, we're talking about nitrogen and phosphorus, and we are changing the balance of that nutrients in our ecosystem through fertilizer, wastewater overflows, mining, phosphorus mining. We're taking so much out of the land that was never on the surface to run off into our coastal waterways. We have just changed the ecosystem so much of Lake Okeechobee that we have so much legacy nutrients in the soil and that's from agriculture, it's from urbanization, it's from changing the landscape. And that's the thing, like, people think that it's just because of farming, and it's just because of fertilizer that we're putting on our lawn, and it's just because of the phosphate mining, and those are all huge problems, and wastewater overflows. But also, we have changed the landscape so much that what used to be a natural breakdown of nutrients by percolation through the soil and breakdown by microbes, and eventually that water is more clean when it gets to the groundwater. We have taken that option away and put concrete on the land so the water, instead of percolating into the ground, runs off really quick. We're getting high peak flows, low water quality, and everything in the state of Florida that lands on the ground goes into our natural water bodies. No matter where you live, it's likely that nutrients have been imbalanced. Like, human activity has played a role in the change in the nutrient cycle, and the water quality is changing with it. So there are just, name a water body and we can tell you what their nutrient issue is.
So, we talk about how pretty much any estuary in the country, in the globe, has a nutrient problem right now. And as far as, fixing these problems, in my short time with Captains for Clean Water, I've realized anything that can get done or that will get done, it has to go through, policymakers. It has to run that cycle through politics. So how does that kind of play a role in this nutrient problem? Does that make it, is it a challenge, or?
It's a necessity. And I learned that the hard way. I was in land development and realized that we were approaching every single project the exact same way. And there was no thought process behind low impact or removing the infrastructure and allowing for that natural water cycle, for percolation of rainfall into the ground. There was none of that. They knew how much it was going to cost and how long it was going to take to do it the same way they've always done it, and they weren't going to change. So I went back to school to prove that there was a better way, because I figured if the research was there, why wouldn't the regulations change that way? And I learned the hard way that one person, one scientist, with one set of data cannot make these huge changes that are ingrained in politics. So what I realized since then is that major changes have only come when the public have gotten together and became a power, became an entity that required, just called for and mandated regulatory change. And we saw that with Love Canal in New York. We saw that with the Gowanus Canal in New York City. We saw that with the BP oil spill cleanup, when a community scientist in a huge group noticed that there was another oil spill happening at the same time, and they got change. All of these groups got change, and the one that I use the most is Captains for Clean Water, because they got a community together to really make a movement and do the things that actually get change done. There's so many groups that just picket and just yell, but the thing is, what needs to be done is shaking hands with politicians and telling them what the problems are, telling them that you have a whole bunch of voters on your side and you're ready to work with them. And that's exactly what Captains for Clean Water did.
So we kind of talked about how this nutrient pollution problem, it's worldwide, it's across our country, and it's not a single source. Like, we can't just put the blame on, one single individual. So that makes it tough at the policy level to make things happen. But I think that puts us in a unique perspective with Everglades restoration, because we have the science there, the plan is already laid out. Is there anything that you can attest to Everglades restoration or anything like that?
Yeah, I really like what you said about it never usually being one thing. During the Florida red tide bloom in 2018, when we had a dual bloom of a toxic species of cyanobacteria with Karenia brevis in our coast, I mean, it was a disaster, and everybody wanted to point the finger at one thing, and I get it, because if they can point their finger at one thing, that means they can change it. And there's just so many things, and so it's just not that simple most of the time. But 100 years ago, when the Army Corps of Engineers saved South Florida people from basically an ultimate doom after thousands of people died after the 1928 hurricane came through, and the Army Corps of Engineers was called in to build a big dam. So now whenever the water gets to a certain level, it's released to the Caloosahatchee or the St. Lucie River. They did their engineering job, but they weren't scientists. They didn't do their science job. They didn't think about the impacts that what they were doing was going to have on the Everglades. They were just at the hand of the people south of Lake Okeechobee that needed to farm and live. And now we're at a place where we're realizing, and this is not just in Florida, this is all over the country, that we're realizing that we manipulated our natural conveyance, our water, so much that it's having serious ecological and water quality problems. And the Everglades is definitely a huge example of that. And bringing that water from Lake Okeechobee south does have its obstacles. We have changed the water quality and quantity so much that now we have really heavy phosphorus loads. And right now, if we released it just as it is right now, it would be devastating to the Everglades. The cattails would outcompete the periphyton, and we would have an ecological shift, which is why the engineering of this process is so important. And storage and treatment facilities south of the lake to bring that water to the Everglades is essential, because the Everglades need water. They are starving of water, and they have enough problems already. Saltwater encroachment, invasive species. Can we please help them out by restoring at least the hydrology? And that's what I'm hoping that we can do in this state, that we can save the most biodiverse place in the Southeast, that we can just, this place is magical. The Everglades are magical. If you go into the Everglades, that experience is life-changing. You will never look at water and wildlife and your own behaviors the same.